Welcome to this first lesson in the video series on regression, Simple Regression on Excel. This is Dr. Stephen Herod at the University of Dayton, and let's get started. Today we're going to look at a very simple regression. A simple regression is a regression with only one independent variable, one x value. Here on the right is our sample data set. We have the independent data on the left, the x data, and we have the dependent data on the right, the y data, and we would like to fit the linear line below to this data. This is the estimated regression. The y equals beta sub 0 plus beta 1 times x. During these slides, during this presentation, we'll look at the residuals. I'll talk about that briefly. We'll look at the estimated regression function parameters. We'll look at the ANOVA table, look at the t-test calculation results, and finally finish out with the confidence intervals of this regression. So let's get started. Let me pull up the spreadsheet and let's see how this works. Here's our spreadsheet with the data all ready to go. We've got our data here in the upper left. We're going to use the data analysis tool in Microsoft Excel. If you don't have this visible, it's because you need to install it. It is an add-in, and you maintain add-ins by going to the File menu, looking at the options for Excel, and managing your add-ins. So let's pull up this tool. Here we go. We want the regression tool in data analysis. Here's regression right here. Select that, and you get a dialog that looks like this. And let me clear this out, because I want this to start from scratch. So here's how it looks if you've never been using this before. Completely empty, no entries made. And now let's look at the top of this dialog and walk through the choices. First of all, it's going to ask for the dependent data, the y data. And so here is our dependent data, our y information right there. Now there's a little extra trick you can do that I am going to do right now. You see this label right here, this box that says labels? Check that. Then go up here and let's change this. Instead of just the data, select the data and the label at the top of the column. Select the whole column including the data and the label, and then check this box labels. What's going to happen is it is now going to see that name and use that name when it makes the result for you. When it presents the solution to you, it can now name things properly with that label at the top of the column. Let's do the same thing for the independent data, for the X data. Let's select the label at the top of the column and the data all together, like that. Now down below, let's check a few more boxes that we're going to use to get some results here. We would like to see the residuals. Let's check that box. We would like to see a plot of the residuals. Let's check that box. And we would like to see a standardized residual. Let's check that box too. We're all done. We're ready to go now. This result will be presented to us on a fresh new worksheet. The new solution will be displayed on a new worksheet, so that button is checked right there. And let's go. Let's do it. So here's our result. Let's zoom in a little bit and see this a little closer. Here are all these results. I'm going to go through these in more detail on the slides here in a minute, but let's take a look at some things on the screen first right now. Here at the bottom are the residuals, the calculated residuals. This is the difference. This is the difference between the fitted line and your original data. So this is the y, the independent, the dependent data, the output result of your data as suggested by the fitted line, and compare that to the original data from your source. And the difference between those two is the residual right here. To the right of that is the standard residuals. That is these original residuals scaled. They are scaled according to a normal distribution with a mean of 0 and a standard deviation of 1. And I won't go into detail of what you can do with that, but it is very useful, and I'm sure you will hear about it sometime in the future in your course. Here is a plot of the residuals. And again, I won't go into detail about how to review this plot, but you will very likely find this useful at some point in regression. Let's take a look at the results item by item here in these slides. Here's the top part of our regression solution. There's a couple of key statistics here. Let's take a look at these. The coefficient of determination, the correlation coefficient, and the standard error of the estimate. All very useful items here in your regression analysis. Down below at the bottom of the solution we have the coefficients. We have the intercept, the beta 0 coefficient. We have the slope, the beta 1 coefficient. Then we have the standard error of the beta 1 coefficient, the standard error of the slope. Then we have the t-test statistic for beta 1. And finally we have the p-value, the t-test p-value right here. Let's take a look at the ANOVA table. Here is our sum square of regression, our sum square of error, our sum square total, our mean square of regression, our mean square of error, and our f-test statistic. To the right of that, we then have the f-test p-value. Finally, we have the confidence intervals. This data is to the right of the second slide before this one, and it gives you the upper and lower boundaries of the t confidence, the confidence intervals based on the t statistic of the parameters. So our beta 1 parameter, our estimated regression, our fitted beta 1 parameter, has a 95% confidence that the true value of that parameter based on a larger population sample is between 1.56 and 8.43. Now you'll notice the same numbers printed to the right on the screen here. I won't go into detail as to why Excel does that, but if you've made no other changes to the dialogues that I showed you earlier, you would expect both of these numbers to be identical, and that's normal, so don't worry about that. So we're all done. I hope you found this useful. Thank you very much for spending this moment with me to learn about how to use simple regression on Excel. Thank you very much.